Moving between UML and a programming language, in this case Java, and back is really important skill. You have to be able to see how UML diagrams translate into code and vice versa, because that'll make it much easier for you to think back and forth between these things, as well as just simply the mechanics of writing code or creating diagrams for the code you've written. So the simple thing to say is Java is an object-oriented programming language. Attributes in UML are attributes in Java. Methods in UML are methods in Java. So when I see attributes and methods in a diagram, they translate to pretty much the same thing here in Java. Name goes to name, price goes to price, get price goes to get price. Similarly, on game board, we have board and player turn and make move, and they translate over here. But in this case, notice I don't know what type board should be, or player turn, or move for that matter. In the first example, I can infer pretty quickly. Either name is a string because, of course, it's a string. That's what names are. They're text. Big decimal is given to me. You can see in UML, I can put a colon and the type right there, and I can say, well, instead of double or integer or something else that might here, I want to use this very specific type from Java called big decimal. But sometimes in UML, I can leave off a type, and it becomes very vague what to do in code. It's not necessarily bad, but it also sometimes can be confusing. Now, I might want to leave it off because putting it in there might make my code my UML very complicated to read, or it might make it like big decimal doesn't exist, for example, in Python or C, so I can't have this diagram be used in more than one programming language. But that's not necessarily a bad thing either, because I don't often code solutions in many programming languages. But just to show you the flexibility of UML and kind of the trade-off between specificity and simplicity. Now, as we're looking at that, did you notice here that the plus immediately goes to public in Java, and the minus immediately goes to private? Pretty simple, but worth pointing out. Now, associations though, in UML don't have a direct corollary in Java, but they become attributes. So when we have our line item here, the quantity of the line item goes straight to being that integer quantity over the side. The product, though, the line, the association to that, also becomes an attribute. In this case, the type is the class I'm associating to product. And the name, because I haven't specified otherwise, the simplest name to give it is the lowercase p product in this case. If there's a name on the other side of here, this could be the thing purchased, then the variable would be thing purchased, for example. The method now has the ability to take advantage of that attribute. So I can say return product.getPrice, multiply it by the quantity. So quite simple logic right there. But now you can see how the logic remains simple as we scale up. We just simply have the product as the price, the line item has the quantity, the subtotal is the price times the quantity. So Java code becomes fairly easy to translate back and forth. And it doesn't necessarily have to show absolutely everything perfectly, but these big concepts is what we need to get across. Now, that multiplicity is an important thing to consider. So if there's no multiplicity or a one, it's just a single attribute like we saw there with product. If I would say line item is 2 to 4 products, for example, I might do that as an array, because if there's a fixed number of them, I can build that fixed number within an array, and I can know there's always that fixed number. But if it's an open number, like with the stars, 0 dot dot star or star itself, then I'm typically going to use a collection or a list or maybe a set or something along that lines that will hold many of them. If there's more than one, I can use a list as well, but again, I can't necessarily specify the number in a list. So particularly if the logic needs to use the first one or the fifth one or something like that, then I need to be careful. So what about constructors? Well, UML treats constructors just like any other method. They just have the same name of the class. They can have whatever parameters you want to. So just like Java, a constructor is kind of like a method, just a special method with no return type and matches the name of the class. So if you see in a UML diagram a method that has the same name as the class, that basically translates to a constructor when you go into Java and vice versa. So going back and forth between UML and Java is not exactly complicated. But getting practice on that is what's going to be important. There's actually tools that you can take UML diagrams and generate Java code, and you can take Java code and generate UML diagrams for. And those are useful, but they're almost always going to either be too specific or not specific enough. So understanding how to do it yourself is also an important skill, and something hopefully you'll get some practice on before the end of your time here with us.